this video, I'll talk about harmonic phase sequence. So, harmonic phase sequence can be determined as follows. So basically you take the harmonic order, typically across industry it's called H, times the phase sequence of the positive sequence, which is 0. Basically, if you have a three-phase system, they are separated by 120 degrees. So 0 degrees minus 120, then 120 degrees. So if we assume counterclockwise positive rotation, which is typically what is considered. So if you have A phase, then you will have B phase here, and you will have C phase, and they're separated by 120 degrees. So as they rotate, if you have someone stationary, if you have a person stationary here, and they are looking, as phase A rotates, then B will follow it, then C will follow it. So if you have this is the positive sequence. And the negative sequence basically would have A, and you would have C, and you would have B. So as they rotate counterclockwise, A will go first. So if you have, like, assume there's a line here, A will cross the line first, C will cross second, then B will cross third. And typically, well, in the zero sequence, the phase difference is 0. There's no phase shift between the phases. So A, B, C are rotating at the same time. So if you have harmonic order of 2, then we'll take 2 times 0 degrees minus 120 degrees, 100, which is equal to 2 times 0 is just 0, 2 times minus 120, which is minus 240 degrees. 2 times 120 is 240 degrees. 0. Minus 240, I can add 360 degrees, and it's not going to change anything. And the other side, I can add negative 360 degrees plus 240, and it's not, I'm not changing anything. So then 0 doesn't change. 360 minus 240 is just 120 degrees. Minus 360 plus 240 is just minus, which is negative sequence. Because positive sequence positive sequence if you have a phase A here, and if you are assuming counterclockwise rotation, phase A, that means phase B would be somewhere here. Phase B is lagging by minus, so it's minus 120 degrees. And phase C would be 120 degrees. So A is the reference, it's at 0 degrees. B is at lagging by 120 degrees, and C is leading by 120. So that's positive sequence. Now if I draw this here, so I have A, I have B is at 120 degrees. So here's B, and here's 120 degrees. And C is at minus, sorry, these are not at equal angles. But here is C, it's negative 120 degrees. So if I assume counterclockwise rotation, if this is a line, A will cross the line, then C will cross the line second, then B will cross the line third, which is negative sequence. So if I have harmonic order of 3, I'll do the same thing. 3 times 0 degrees minus 120 degrees, 120 degrees, which is equal to 3 times 0 is just 0. 3 times negative 120 is minus 360. 3 times 120 is 360 degrees, which is really equivalent to 0 sequence, because 0 and 360 is at the same position. This is 0 sequence. Because if you take a circle, here's the origin. If you take this as 0 degrees, if you make a full circle, that's at 360 degrees. If you make another full circle, it's 720 degrees. You basically just add 360. And if you go like, if you start from negative, before 0, it's minus 360 degrees. So the main thing to remember is, if we assume positive rotation is counterclockwise, which is universally a convention, then just draw phase A as your reference, A, and you have A, B, C, and if they are balanced, they are apart by 120 degrees. That means one phase will be here and one phase will be here. So A, B will be here. That's minus 120 degrees, because 0, or the reference is here. A is at 0 degrees. Then from A to C, it's plus 120 degrees. So this is positive sequence. Positive sequence. Because if you draw a line here and you are stationary, so you are somewhere here stationary, and you are looking at which one will cross as they rotate counterclockwise. A will be first, B will cross second, then C will cross third. So ABC phase rotation. So we'll do another one. If we have H is equal to 4, then you do 4 times 0 minus 120 degrees, 120 degrees. So 4 times 0 is 0. 4 times minus 120 is minus 480 degrees. 4 times 120 degrees is 480 degrees. So 0 just 0. This here I can write as minus 360 degrees minus 120 degrees. So it's still minus 480. 480 I can write as 360 degrees plus 120 degrees. 0 degrees. So like I was saying, minus 360 degrees is the equivalent of 0 degrees basically. Minus 120 degrees. 360 degrees is the equivalent of 0 degrees plus, so which is equal to 0. 0 minus 120 is minus 120 degrees. 0 plus 120, it's 120 degrees. So I started with this, which is positive sequence, and I ended with the same. So this is positive sequence. I'll do the same thing for a harmonic order of 5. So again, 5 times 0 minus 120 degrees, 120 degrees. 5 times 0 is just 0. 5 times minus 120 degrees is just minus 600. 5 times 120 is 600 degrees. So 0 degrees doesn't change. So I can write this as 720 degrees minus 600 degrees, and I'll explain why I did that. The other one I can write as minus plus 600 degrees. Notice here I added 720 is because I know that's an equivalent of 0 degrees, because it's 2 times 360 degrees is 720, which is the same. So okay, I'll write 0 first. 700 minus 600 is just 120. And the same thing here, this minus 700 is really the equivalent of 0 degrees, because it's 2 times minus 360, which is a full circle. So minus 120 plus 600 is minus 120 degrees, which is negative sequence. Negative sequence. How do I know that? Because I know this is the reference A phase, this is B phase, this is C phase. So let's draw them. So I have A phase at 0 degrees, which is the reference. I have plus counterclockwise rotation, so phasors are rotating that way, which means if I go, as I go this way, I'm dealing with positive angles. If I go reverse, they're negative. So B is at 120, that means B is somewhere here, because this is 100. And remember, these are not to scale, but you get the point. And C is at minus 120 degrees from the reference, which is A. So again, if I have a line here, as they rotate, A will rotate first, will cross the line first, C will cross the lines second, then B. So it's ACB, which is negative sequence. And since in general in a since in general a distorted and basically you can do this for any or h equal to k, any number, basically you can do that. So as we know, typically any distorted waveform in power systems or in a power system typically only contains odd harmonic components. Odd harmonics, that means h equal to 1, 3, 5, 7, so forth. Just odd numbers, basically. So then we can write h is equal, if it's 1 or 7 or 13 and so on and so forth, those are positive sequence. And you can go through the exercise that I went to. You can take 7 times that phase sequence of 0 degrees, minus 120 degrees, 120 degrees, and if you go through, you will find that, indeed they are positive sequence. H equal 5 or 11 or 17 are negative sequence. And triplets, basically h equal 3, 9, 15, so on and so forth, are 0 sequence. So they're called triplet harmonics. So triplet, that's 3 times a number, but they're odd numbers. So that's basically how you can find the harmonic phase sequence. So in general, I can write up to 18. So if I have order harmonic H, and I have phase sequence. So I have 1, 2, 3, 4, 5, up to 6 here. So 1 is positive sequence, 2 is negative, 3 is 0, 4 is positive, 5 is negative, and 6 is 0 sequence. Then I can do the same thing here. H and phase. So 7, 8, 9, 10, 11, 12. So basically you keep going. So positive, negative, 0 sequence, positive, negative, 0 sequence. So you kind of see the trend. H, phase sequence. So 13, 14, 15, 16, 17, 18. Positive sequence, negative, 0, positive, negative, 0 sequence. So that's basically how you can figure out what is the phase sequence or the harmonic phase sequence. I hope you find this video useful. Thank you and have a great day.